Hello and welcome to the channel. Today we're going to talk about one of the strangest and, at the same time, most important topics modern science can touch. The topic sounds provocative: quantum physics is shattering the concept of death. Let's make an important clarification right away, so we stay honest and accurate. Mainstream science does not claim that death has been cancelled or that immortality has been proven. However, discoveries in quantum physics increasingly undermine our familiar understanding of reality, time, matter, and, as a result, what we call death. We are used to thinking of death as a clear final point. A person existed, and then they are gone. There was consciousness, and then it disappeared. This logic feels obvious because it grew out of classical physics and biology. But this is exactly where the problem begins. The classical picture of the world is no longer fundamental. It works at the level of everyday experience, but it stops being accurate when we descend to the most basic level of reality. Quantum physics has shown that the world is structured very differently from what we once believed. At the fundamental level, solid objects do not exist in the familiar sense. Particles can behave like waves, waves like particles, events do not always have a single clear cause, and observation itself affects the outcome. All of this is not philosophy or imagination, it is experimentally confirmed fact. In the quantum world, there is no sharp boundary between exists and does not exist. A particle can be in a superposition of states, existing in multiple possibilities at once until an interaction occurs. This means that the very idea of absolute disappearance becomes far less obvious than it is in the classical worldview. One of the most disturbing and at the same time fascinating questions is this: if matter at the fundamental level does not vanish, if information is not destroyed, then what does that mean for the concept of death? In modern physics, there is the principle of information conservation. In simplified terms, it suggests that information cannot be completely destroyed, even if the form in which it appears changes radically. This principle is actively discussed, including in the context of black holes and the structure of spacetime. And here it is important to emphasize, this is not about physicists claiming the existence of an afterlife. It is about the fact that the fundamental laws of reality do not support the idea of absolute nothingness in the way we are used to thinking about it. The classical idea of death rests on a simple model: the body stops functioning, the brain shuts down, consciousness disappears. But quantum physics forces an uncomfortable question: what if reality is deeper than this linear chain? What if consciousness is not merely a byproduct of chemical reactions, but is somehow connected to a more fundamental level of reality? Some interpretations of quantum mechanics suggest that the observer plays a fundamental role in the formation of reality. This does not mean that consciousness creates the world, but it does mean that without observation, a quantum system remains in an indeterminate state. The very fact that observation is part of the physical process already destroys the familiar separation between an objective world and a passive observer. If consciousness is somehow woven into the structure of reality, then the idea of its complete and final disappearance becomes far less obvious. Not proven, but not obvious either. And this distinction is crucial. Quantum physics also undermines the linear view of time. In the classical picture, time flows strictly from past to future. But at the fundamental level, many physical equations work equally well in both directions of time. Moreover, there are interpretations in which past, present, and future are parts of a single structure, and our sense of time flowing is a feature of human perception. If time is not an absolute stream, then death as a final point in time loses its clarity. It becomes an event within a structure, not a complete termination of existence. The question of information and identity is especially intriguing. If personality is not only the body, but also a structure of information, a pattern, a way experience is organized, then what happens to that information when the biological form breaks down? Modern physics does not give a final answer, but it increasingly emphasizes that information is a fundamental category, not a secondary byproduct of matter. It is important to be honest: quantum physics does not prove that personal identity survives death. It does not describe what happens next. But it does dismantle the old certainty that death is a simple and final disappearance into nothing. It shows that reality itself is far stranger, deeper, and less intuitive than we once thought. Another point that is often overlooked: quantum physics does not offer comforting answers. It does not promise heaven, nor does it paint a picture of an eternal self in the usual sense. On the contrary, it strips away simple explanations. But that is precisely its strength. It forces us to admit that our ideas about life and death are models, not absolute truths. Fear of death is largely based on the idea of total annihilation, on the belief that everything we are will be erased without a trace. The quantum picture of the world does not directly confirm this idea. It leaves the question open. And sometimes an open question is far more radical than any answer. Why is this rarely discussed openly? Because science is extremely cautious in its interpretations. Physicists prefer to speak in the language of equations rather than existential conclusions. And that is appropriate. But the philosophical implications of scientific discoveries do not disappear just because they are not spoken out loud. We live in an era where fundamental discoveries are slowly dismantling our familiar picture of reality, not loudly, not abruptly, but gradually and relentlessly. And the concept of death is one of the ideas that no longer looks as clear and unambiguous as it did 100 years ago. To summarize, we can say this: quantum physics does not abolish death and does not promise immortality. But it does dismantle the simple mechanistic idea that reality is just a collection of objects that appear and disappear forever. It shows that the world is deeper, stranger, and more mysterious. And that means the question of death requires a much more careful and nuanced approach. If you're interested in topics at the intersection of science, philosophy, and human experience, if you want to understand not only discoveries, but their implications for how we perceive life, subscribe to the channel. In future videos, we'll continue exploring how modern science reshapes our understanding of reality, consciousness, and existence itself. These are not answers. This is the beginning of more honest questions.